Hi, so we're going to be doing today, we're going to be looking at a pattern. And the pattern at which we're going to look at is called a matchstick pattern. And I have that demonstrated right here to my left. What we're going to be doing is creating an algebraic rule for the pattern. So I'm going to go ahead and write that down here. What we want to find is our rule for our pattern. And how we do this is we're going to start by creating a table. And in our table, we have the number of squares on our left and the number of toothpicks on the right column, on the right side. So, what I mean by this is the number of squares would be 1, so I have 1 square there, 1, 2 squares here, 1, 2, 3 squares here. So now I need to go in and fill the right side of my column, of my table. And I have 1, 2, 3, 4 toothpicks to create my 1 square. I have 1, 2, 3, 4, 5, 6, 7 toothpicks that create my 2 squares. My 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks create 3 squares. So I'm going to go ahead and write that down here. And you know what I notice? I notice that on my right side of my chart, of my table, that I am going up by 3. I notice that 4 plus 3 equals 7. That 7 plus 3 equals 10. So you know what I'm going to go ahead and do? I'm going to go ahead and find how many toothpicks there be in 4 squares. Because if it's going up by 3, I know that it's going to keep doing that because it's a pattern. So I know that in my 4 squares, I'm going to have 10 plus 3, which is 13. I'm going to have 13 toothpicks. But you know what? What if I wanted to find the 20th term? In order to find this term, I can't just jump straight there. I have to find the 19th term, and to find the 19th term, I'd have to find the 18th, and so on and so on. And that might be a little hard. It'll be a little time consuming. So what I'm going to do, I want to find a rule. I want to find something that will tell me how many toothpicks there will be in the number of squares. So if I want to find how many toothpicks there will be, all I'll have to do is put in how many squares into my rule, and it'll give me the answer. So in order to do this, I'm going to go ahead and break up 4, 7, and 10. And what I notice is that 1 plus 3 equals my 4. And you know what? I chose this for a reason because I also noticed that 1 plus 3 plus another 3 gives me 7. Kind of starting a pattern here, right? We can see it by knowing that this 1 plus 3 plus 3 plus 3 is the same as when we realize that we're going up by 3 each time, because we're adding another 3 as we go up in squares. So what I'm gonna go ahead and do is I realize that I have groupings of 3. So I'm going to go ahead and write this out. I have one group of 3 plus my 1. And then I have 2 groups, because I have 1, 2 of 3 plus 1. And then here for my 3 squares, I have 3 groups of 3 plus 1. And when I hear groups, I automatically think of multiplication. And I know that one group of 3 is the same as saying that 3 times 1, because I have one group, is the same as one group of 3, and then I'm going to add my 1. And then I know that if I have 2 groups of 3, that is the same as saying 3 times 2. Then I'm going to go ahead and add my 1. And then I have 3 groups of 3. I'm going to go ahead and add my 1. Now that I have this, I realize that these numbers, the number of my groups, actually match my number of squares. So what I'm going to do is I'm going to go ahead and plug in S, meaning the number of squares. And when I do that, I'm going to get my rule. Now I realize that 3 times S plus 1 is the same as 3 times 1 plus 1. And then here I can add in S as my 2, because I have 2 squares here. I'm going to go ahead and add the S as my 3, because I know I have 3 squares there. And this gives me my rule. I know that the number of toothpicks, which I'm going to represent as T, is equal to the number of squares times 3 plus 1. This is at least what I think it is. And you know what I'm going to do now? I'm going to go ahead and go to this 4, which I found out by finding the next number in our pattern. I'm going to go ahead and plug this in into my rule. If I know that this is my rule, I can put 4 into the spot where you're supposed to put the squares. So I know that 3 times 4 plus 1 is going to give me the number of toothpicks. So let's see. 4 times 3 is 12, plus 1 is 13. And you know what? That matches, because I know that 13 was what I got with my rule, and when we calculated it earlier, we knew that 13 was how many toothpicks there was in 4 squares. So I have now checked to make sure that my rule is correct. And so now that I've done that, and I know that it's right, I'm going to go ahead and find how many toothpicks are in 20 squares. Because this is a big number, and I know that I don't want to count up by 3 each time, so I'm going to use my rule. And I know now that 3 times the number of squares, which in this case is 20, because we want to find 20, plus 1 is going to give us how many toothpicks are in 20 squares. So 20 times 3 is 60, plus 1 is 61. So this tells me, by using my rule, that if I had 20 squares, there would be 61 toothpicks in those squares. So what we've done here, we've created a rule to make our lives easier. So we now know that we can find any amount of squares and find how many toothpicks make up those squares. We now know that we can find anything using this pattern rule. So thank you very much. This is used for 4th grade. This is appropriate for 4th grade. Kids start using patterns in kindergarten, but they wouldn't start deriving the rule for it until about 4th grade.